And welcome. Thank you for joining today's webcast, Enhancing Emergency Prep, Microgrid Devices for Building Ops and Facilities. I am Paul Ellertson, and I am the webcast producer here at Trade Press Media Group. We certainly appreciate you joining us today for this event. I do have a couple housekeeping items to cover before we jump right in. First of all, we do encourage audience questions throughout the webcast. To submit your questions, just please navigate to the bottom of your screen. You should see a Q&A Ask Questions module down there. So please submit your questions at any time. If you'd like a copy of today's presentation slides, they can be downloaded in the related content module. Now that should be probably just under my video screen here. And if you'd like to receive a copy of the presentations, I just said that, sorry, a presentation recording will be available on facilitiesnet.com. So if you want to watch a recording of this will be archived on facilitiesnet.com. And to receive a CEU certificate, you must watch 40 minutes of the webcast. Then you can submit for credit and download a certificate by clicking on the View Certificate in the Earn Certificate module, which again should be actually on the right side of your screen. Enough of the introductory notes. Today we do have Robert Benavides joining us, along with Victor Bonachet. Robert is Business Development for Renewables with ASCO Power Technologies, and Victor Bonachet is the Director of Product Strategy for ASCO Power Technologies. So without further ado, I will pass it over to Benny.
Yeah, thank you, Paul. Nice to meet everyone today, or good morning, good afternoon. As Paul mentioned, today's presentation is on microgrid interconnection devices for emergency systems. This is a fairly new product. It's been referenced in the National Electric Code, and it's a product here that safely disconnects from the grid and enables a battery energy storage system to be used for emergency systems. So taking a look at the agenda, we're going to go through what is a microgrid interconnection device, those characteristics and purposes, give you some updates on the National Electric Code, talk about the application of a microgrid interconnection device, right? How that's utilized in a single line diagram, go through a visual learning, so an animation that we put together to highlight how this interconnection device works, and then open it up for Q&A. I have my colleague, Victor Bonachet here. So as you guys have questions, feel free to post them in the chat. We'll do our best to answer them. Any questions that require, a little more in-depth response, we'll, contact you right after this webinar is over. So a little bit about myself. I've been with ASCO and, a business entity of Schneider Electric for going on 12 to 13 years. I started my career in the Mid-Atlantic. So right just outside the DC area, Northern Virginia. I spent some time in sales, marketing, and strategy. And I made my way over to California, where I currently reside in the Bay Area. For those that are familiar with California, there's Title 24, which requires PV and energy storage installations for residential commercial builds. So really capturing those trends, working with customers here locally and then nationally on how we can design these microgrid systems, not just for the grid connected services, but also find unique ways to have these microgrids operate for emergency systems. And that's been the focus of ASCO Power Technologies. If you're familiar with ASCO, we've created the first automatic transfer switch. We actually completed our first 100th year anniversary with the ATS. And then we also provide parallel switchgear solutions, so multiple generators on a common bus, to provide emergency power. With that, we enter the space in the renewable segment here with this microgrid interconnection device to enable battery energy storage systems for emergency power. So to kind of give you guys a backstory where ASCO is and why we're in this space today. Before I go into it, I also do have my colleague here, Victor Bonachet. Victor, I'll leave it up to you to introduce yourself real quickly.
Yep. So I'm on this webcast today to help support some of the Q&A, but my name is Victor Bonachet, Director of Product Strategy for ASCO. My academic background in electrical engineering with a specialization in power and controls, as well as engineering management. And I've been with ASCO for 14 years now. So over those years, been in various roles from application supporting field and projects to R&D and my current strategy role. And in that time, I've helped contribute to several new products in our portfolio, many of which resulted in patents, most recently SourcePack, which we're going to be talking about today. I'm involved with code and standards development, both through IEEE and NFPA, and just very interested to support where I can, and kind of watching the back. I'll be monitoring the Q&A. Certain questions I'll be answering as they come in. Some we might save for the end to answer verbally, and some maybe are a little bit more complex to answer, so we'll answer maybe after the fact and reach out. So feel free to drop those in. I'll jump back on at the end, and we'll answer any questions that come up during the presentation. Thank you.
Excellent. Thank you for that, Victor. So yeah, we'll dive right in here. So, what is a microgrid interconnection device? We like to show the slide, and if you see there on the bottom right, we like to use the analogy, what an ATS is to a generator, SourcePack, the brand name, a microgrid interconnection device is to a battery energy storage system. And this is the industry's first UL 3008 automatic interconnection switch that's designed for emergency systems. So prior, almost like an ATS, if you had an ATS for a NEC 700 emergency system or NEC 701 legally required system, it required an automatic transfer switch there to transfer over to that emergency power system. Here with this automatic interconnection switch, it enables you to disconnect from the grid and signal this battery energy storage system to be utilized for emergency system. And as you can see there on the left there, we have the SourcePack product, which is essentially a electrically operated breaker with a controller. So very similar to a transfer switch, where the controller is sensing voltage and frequency and is connected to this electrically operated breaker where it disconnects and the controller signals this energy storage system to come online for emergency conditions, very similar to what an ATS would do for a generator. So we like to show this slide here to kind of distinguish the two differences between a transfer switch and an automatic interconnection switch. If we look at the left side, and a generator is typically not connected to the utility. It requires the transfer of a load to an energy source. And what we mean by that is when the transfer switch loses power, it will remain connected to source one. And then once it senses that source two power is available, i.e. the generator here, it would transfer over to source two. And the reason that is, the transfer switch requires a power source to energize our solenoid operator, the transfer switch operator, to transfer load from source one to source two. If there's no source two present there, the transfer switch will stay connected to source one, which kind of distinguishes the key differentiated piece here, where an automatic interconnection switch also comes with the controller. It monitors voltage and frequency. Once it detects an outage, the electrically operated breaker in this device will open, safely disconnecting from the grid, signaling the energy storage system that, hey, we're now safely disconnected. You can change state from grid tied to grid forming. Why is it different for battery energy storage system? Well, primarily battery energy storage systems are grid connected devices, different than a generator. There's a lot of use cases that come with the battery energy storage system, and I'll highlight those in the next slide. Whether it's time of use management, self-consumption, the utility's present, for at least like 99% of the time. And then when we lose power, we want to enable that energy storage system as an added use case to provide resiliency to those critical loads in your infrastructure, rather than have that energy system just sit down or in the dark without any functional use. And that's where the automatic interconnection switch comes in here to truly disconnect, and is designed and UL listed specifically for this application. So if we go through just the list of energy storage use cases, you can see there's quite a few here. I would say one of the primary reasons why these energy storage systems get adopted into a facility for demand charge reduction, right? You're hitting peak values throughout your utility rates. You go over, and then once you hit that utility demand charge, sometimes you get charged that rate for the rest of the month, for longer duration of that period. And really, once you hit that demand charge, really your utility rates kind of skyrocket. So most energy systems are implemented here to reduce those demand charges, keep you within the allocated limit. But there's also other use cases of time of use management. If you live in the state of California, you get charged a higher peak rate during the hours, 4 to 7 p.m. Sometimes you can go along even further. Self-consumption, right? Depending on the geographic region, few years ago was beneficial, where you can export back to the grid. Now, believe it or not, if you have these on-site generating assets, whether it's PV and or energy storage system, it's actually cheaper to produce power on-site and consume it for your facility rather than purchase it from the utility at certain hours. Demand response, participate from a utility program to help with frequency regulation, incremental power, right? If you don't get the approval rating from the utility, for an expansion, an energy storage system can help suffice that incremental power that your facility needs for operation. And then we're going to go through here, and the main piece here is for resiliency of backup power. So as I mentioned, all these use cases, everything I mentioned above is for grid connected, when the utility is present, right? That's when your energy storage system is making financial sense for your facility. But at the same time, when you experience an outage, you would also want to use that energy storage system for some type of backup power or resiliency. So in the event of an outage, you can use this energy storage system to provide power to emergency loads in your facility and also non-emergency loads, depending on the type of facility you have. So how does this microgrid interconnection device operate? Well, SourcePack, our product, has a controller that monitors utility and inverter-based power. So the controller is monitoring utility power on top of the breaker, source one, and at the bottom is monitoring inverter-based power. Now, upon a utility failure, this microgrid interconnection device acts as a grid isolation device. So it opened that electrically operated breaker, separating the utility and non-essential loads from emergency power. Now, why is it important to separate your non-essential loads from utility power? These energy storage systems have a finite amount of capacity. So when you experience an outage, you already want to have in your facility, have it designed so when you experience an outage, your essential loads, the ones that require emergency power, are separated from the non-essential loads. So your energy storage system could provide at least 2 hours of runtime and specifically provide backup power to those specific loads without dispersing energy throughout the entire facility for loads that don't require that emergency power. Additionally, once utility is restored, let's say you're on emergency power mode with your energy storage system, SourcePack, the controller, will detect that utility is returned. So it enables a safe transition back to utility. Once the controller senses that utility is present, the controller will send a signal to the energy storage system or the energy management system in charge of the microgrid, instructing the system that utility is returned. It will shut down those inverters, tell those inverters to shut down, to basically go into grid tied mode again. We're operating in grid interactive mode, we're connecting back to the utility. It will close that breaker, and then your microgrid or your battery storage system is operating grid interactive mode, back under normal conditions. So we have the way SourcePack communicates is through a C-form contact signal. It's a relay, and we're basically vendor agnostic. So any energy storage system or energy management system that can accept the C-form contact relay, we can communicate with them. Very similar to the way our transfer switches are designed, compatible with mostly any generator. Same concept here for the microgrid interconnection device. And this is the UL 3008 listing, which is important in this marketplace as energy storage systems have commercialized. They're readily available. And if you want to use an energy storage system for an emergency application, the National Electric Code requires some type of UL listed product like a transfer switch, specifically designed to isolate from the grid and enable that energy storage system for emergency power. And we'll go through the UL 3008 listing criteria, but it goes through a significant amount of testing criteria to ensure that it's specifically designed to open and close with the utility to enable that energy storage system for backup power. And we also highlight here, we have a vendor agnostic. Schneider also has an energy storage system that's compatible with this product. So it doesn't matter whether it's a Schneider BESS or a third-party BESS, depending on KW, as long as they can accept the C-form contact, we're compatible with any energy storage manufacturer in the industry. So what makes SourcePack unique? I would say it's the simplicity without the complex controls. So if we highlight and zoom into this microgrid interconnection device controller, it monitors and synchronizes between inverter and grid power. So equivalent to the same functionality of a protective relay. In today's industry, you'll see very commonly like a Schweitzer relay being utilized. that will be programmed, interconnected with some type of contactor, and that protected relay senses an under voltage setting. It would open that contactor, and then when utility returns, it will close that contactor again. That solution works for most applications. However, that solution is not truly UL listed for the automatic interconnection functionality for emergency systems. The communication, as I mentioned, we use a C-form relay contact to indicate utility power and inverter-based power, along with failures associated with battery energy storage backup power. So it's a normally energized relay. We send a contact signal to the energy management system or the inverters in that battery energy storage system to signal when utility is present, when utility is lost, when our device is isolated, to allow that energy storage system to come online and safely provide emergency power. Additionally, when utility returns, that breaker remains open, and then we signal again the energy storage system to change state from a grid forming to grid tied. So essentially, if you look at SourceBack, it essentially has a very basic microgrid controller and the actual hardware of the electrically operated breaker to disconnect from the grid. It comes with the electrically operated motorized operator, so it isolates the emergency system from non-emergency loads when normal power is interrupted. We're going to go through National Electric Code and highlight why this is important. But as you design your microgrid systems, you want to ensure that when you use your energy storage system for backup power, you have those essential or emergency loads separated from your main switchboard, so you're not providing power to the entire system. And all this is linked back to the UL 3008 listing, and is approved for emergency systems. So in the code, it requires if you use energy storage system for an emergency system application, you need to have a UL listed product specifically intended for this application, an automatic interconnection switch to disconnect from the grid and enable that battery energy storage system for backup power. So we're going to jump into the National Electric Code, and I'm going to highlight Article 700.12, where now it highlights where energy storage systems can be used as an acceptable means for emergency and optional standby power. So before 2023, I used to get the question asked quite frequently, well, Benny, can we use energy storage systems for emergency power? In 2023, National Electric Code, they not implemented that in. So whether that's battery, some different type of chemical technology that could be used for an emergency system. In addition, it references if you use this energy storage system in parallel operation with the normal source, you can use that on-site energy asset and energy storage system for emergency power. You just need to ensure that if you intend to use that energy storage system in parallel operation with the utility or normal, that it has at least 2 hours of runtime in that system. So in the event of an outage, you can disconnect from the primary source, and there's enough energy capacity in there to provide at least 2 hours of runtime to your emergency loads. Also within, as we kind of dive through, you'll see a section G, microgrid systems. And essentially what highlights here is that the system shall isolate the emergency system from all non-emergency loads when the normal electric supply is interrupted. Now, why is that important? And if you think of your battery energy storage system, if that's connected to your main switchboard has, essential, non-essential loads all connected to one piece of equipment. And if you're going to open the utility main breaker and then have your energy storage system provide emergency power, that entire main switchboard is going to get emergency power. And if you want to shunt your breakers within that main switchboard, now you're modifying breakers. So essentially, it's when you're designing these systems and you intend to use the energy storage system for emergency power, you just want to make sure you have your emergency loads separated on different panel boards or switchboard, where in the event of an outage, you can safely disconnect from the utility and just segment those specific loads for emergency power as it's indicated in the National Electric Code. And then as well, the reference interconnection or transfer switch equipment is not acceptable as a means of interconnection and transfer. So it just shows you here that interconnection switch is an acceptable means of connecting to an emergency power source for these applications. And lastly here, I want to highlight this diagram that's in the National Electric Code. And if you could see there, I don't want it to be an eyesore, but highlighted there in green is the microgrid interconnection device. And if you look to the right, you have the primary source, which is in this case could be a utility. And then to the left, you have your inverter-based resources. It could be a photovoltaic system. some type of carport, rooftop, solar system. If you go up one, you see a multi-node inverter. This is the energy storage system. Energy storage systems have a bidirectional inverter, so they can either charge, acting as a load, and they can discharge out into your AC system, acting as a power source. So that's really where the advantage comes for an energy storage system. And if you notice there, each of these inverter-based resources has a source disconnect. The source disconnect is still required by code, right? So if you want to come and disconnect your PV system, you still require one for code, whether it's for maintenance or service, to ensure that system's offline. The microgrid interconnection device is here. The purpose is to safely disconnect from the primary source. So this device is bidirectional. It's capable of operating with the National Electric Code references as grid interactive mode with the primary source, and has the means to disconnect from other sources to operate that microgrid in island mode. So island mode is the resiliency of the system. So if you want to use that microgrid for emergency power, it's the island mode feature here in the microgrid interconnection device that will enable it safely disconnecting from the grid. This microgrid interconnection device is the point of interconnection between the primary power source and the microgrid system. So you see there, it's that junction, is that in between, almost like a transfer switch between utility and generator. It's the same concept here between the primary source and your microgrid system. And they want this product to be evaluated and have a field listed application here. So this is where the UL 2008 listing comes into importance, because it's specifically designed to interconnect and disconnect from the primary source for this application to enable the island mode in the microgrid. And then the equipment approval rating, interconnection and interactive equipment intended to connect to or operate in parallel with the power source shall be listed for the required interactive function or be evaluated for such functionality with the field label or both. So again, it goes back to the UL listing. A lot of this is relatively new technology, right? So it depends on the facility, the criticality, if it's an emergency system legally required. If that's the case, you definitely want to look at SourcePack and microgrid interconnection device to satisfy the UL listing requirement to ensure that you're using the energy storage system correctly with the UL listed product. So we're going to go into the UL 3008 standard for grid isolation devices. This UL listing was a creation and partnered with UL to fulfill the need of the deployment of these energy storage systems. So it combines the robust parts of the UL 49 UL breaker listing and the UL 1008 listing for transfer switches. And this automatic interconnection switch is put through rigorous mechanical testing. So it's tested 2,000 times with load. So, when you detect the utility outage, the breaker opens, closes back, that's one cycle. 1,000 times without cycle. Again, this is a bidirectional device. 50x the cycle overload rating at 6 at the current, temperature rise test, withstand close-on ratings. All that testing criteria and robustness, you would want an interconnection switch to ensure that if you're going to use that energy storage system for an emergency system, you have a device that's specifically tested that can enable that energy storage system to come online with some type of UL standard. Additionally, we tested the controller as well that allows for that grid interconnection mode with the primary source to detect an utility outage and then disconnect from the primary source to enable this microgrid to operate in island mode. So it's a UL certification. You can see there on the right. Any questions, please post them in the chat. So we'll talk about the C&I market segments. C&I can refer to as a commercial, building, education, government facility, warehouse, manufacturing. It's essentially where a lot of the manufacturing and emergence of these on-site microgrids are becoming more prevalent. And as we're seeing, the common energy storage system for commercial application are between like 100 to 1,000 kW. And that's typical within this C&I segment. And most of the common voltages here are 480 and 208 volt. And I highlight here the current output rating of these energy storage systems. So if you're dealing with the 480 volt system, 100 kW, you're getting about 130 amps. And really the most common sizes go all the way up to 1 megawatt or 1,000 kilowatts, where you get about 1,500 to 1,600 amps of full load amps to your system. Now, why is that important? Because when you're designing your system and you want to use an energy storage system for emergency power, you want to connect that to some of a panel board or switchboard where you have those loads already isolated, and making sure that you're sizing your equipment correctly, right? You don't want to oversize your main switchboard to have your energy storage system, your utility, your PV system, because then you go from a 1600 amp switchboard, 2000 amp switchboard to a 4000 amp switchboard. So it's really important to keep mind of these current ratings and these power ratings, these energy storage systems, so you're sizing your system correctly. 208 volt is also another configuration very common in the CNI segment. Most energy storage systems have a 40 volt transformer that outputs voltage. The 208 is prevalent as well, and we also offer this product in 208 voltage configuration, so it eliminates the need of additional transformer, and again helps reduce and simplify the design in an electrical facility. So this is a K through 12 single line diagram I like to reference. This was in an existing facility for a school. And if you see here, there's an energy storage system, a 250 kW with about 1100 kilowatt hour energy rating connected to a BESS combiner panel. And if you can see there to the right, just north of that combiner panel, there's a transformer, which is transforming it from a delta to Y connection. And if you can see there to the right, there's a microgrid interconnection device. As I mentioned earlier, these energy storage systems are readily commercialized, and the way consultants and integrators are disconnecting from the grid is they're assembling solutions either with a protective relay and contactor or some type of unique relay type of system to disconnect from the grid to enable battery resiliency. And what we're finding out is, in order to offer the client, maximum potential from the energy storage system, in addition to all those grid connected use cases I highlighted earlier, resiliency is becoming an important piece to getting that approval for these facilities. So here they want to use the energy storage system not only for the energy optimization piece, but they also wanted to enable that energy storage system for backup power. And if you can see to the left, they have on the load side there some emergency panel that in the event of an outage, this energy storage system will provide emergency power to that system. So here in this, we actually took this interconnection device and replaced it with SourcePack. So SourcePack was the point of interconnection between the main switchboard and the energy storage system. And this client already had separated their essential loads. Again, this was great for an existing facility, right? If you're an existing facility that has space on your main switchboard, a spare breaker, SourcePack can be that point of interconnection between that main switchboard and your critical loads, adding on an energy storage system and or PV system to your facility, getting those grid connected benefits and also the resiliency. Now, if you see here, I've highlighted some red dots throughout the single line diagram. This shows you just the points of interconnection. This project happened in California. Most utilities prefer not to have multiple points of interconnection. They want just one. So what SourcePack was able to do in this design, we eliminated 2 of these additional points of interconnection and just connected directly to the main service breaker here, where the utility, that was a preference for the utility for simplicity and easy approval. And that's the microgrid interconnection device they're highlighted. Now, also want to highlight here, just again, this doesn't replace that BESS disconnect switch. You still require that per code to disconnect and provide service and maintenance to your inverter-based resources. So that was still included there. This is another opportunity that we've worked on with the client here. This is for commercial building. In this facility, they use the energy storage system as a backup power source, specifically for an elevator system. And you can see they're highlighted in the bubbles to the left. That's the microgrid interconnection device. This is a 1200 amp service. So you can see at the bottom, we have a 1200 amp service. One of the breakers is feeding to SourcePack, and then upstream of SourcePack is this panel board where you have the energy storage system and an elevator circuit connected. So what the client wanted to do here was they wanted to add an energy storage system to provide backup power to this elevator. And what was important for this facility, it was a legally required facility. So they wanted a UL listed product. And they wanted to use this energy storage system specifically for a legally required standby system. So we were here, they actually had the transfer switch installed here. We actually ripped and replaced the transfer switch with the automatic interconnection switch. Same dimensions here. This was a 600 amp product. And this enabled the energy storage system to really save time on deployment. Given the UL listing, a lot of these, depending on the ASJ, they require third-party testing. And if you don't have a UL listing, it requires you to go through some type of third-party agency and actually test that this device is intended to operate as an automatic interconnection switch, which in this case, we had these products readily available in stock. We were quickly able to ship out and bypass that third-party testing. And then when we lose power here, the device disconnects from the grid and it provides emergency power just to that elevator in the event of an outage. Here it's a parking garage, so the application worked well for this design where SourceBack helps streamline the resiliency in this energy storage system. And this was a small energy storage system, about 125 kW rating. But I'll say for most commercial applications, again, it goes to that sweet spot, primarily 100 to 500 kW. You'll have some times where they go up to 1 megawatt, have multiple 1 megawatt energy storage systems. Really anything over 1 megawatt, those are used primarily for grid connected use cases. You can also use them for resiliency. It's just at that time you're dealing with a lot more power. So the use cases change, but conceptually, they all have the same functionality. They can operate in resiliency as well. So these are some of the core architecture. So in most single line diagrams, I would say most of them, the battery only scenario will have a photovoltaic system, and the client will add some type of energy storage system there to help reduce peak, to help perform peak shaving, take advantage of time of use management. And most facilities will have PV and or energy storage system. There's some opportunities here. If you scroll to the middle here, you'll have battery and generator. Or perhaps maybe it's an existing facility. They had a generator there that was providing power to legally required loads, and this facility now wanted to add a photovoltaic and energy storage system to tap into the energy economics of the microgrid, right? So in this case, both ATS and automatic interconnection switch here are independent. So picture like a main switchboard, and ATS is downstream as well as an interconnection device. And both of them will operate independently. So upon an outage, the ATS will transfer to the generator in its respective loads, and the automatic interconnection switch will also disconnect, enabling the energy storage system to provide power to its own respective loads. And I'll go through this animation. Just kind of shows you here there's different ways to configure a single line diagram to have your energy or your microgrid system provide backup power. And then to the right here, we have a battery first scenario, where in this scenario here, your battery energy storage system comes online first before the generator. How this design works is the energy storage system is primarily connected at the main switchboard, and downstream from the main switchboard is an ATS with a generator. So in the event of an outage, SourceBack's automatic interconnection switch will open from the main. It will signal the energy storage system to come online. Inverters come online almost instantaneously, so the point of outage, so say under a second, you can have emergency power. So the ATS will technically, depending on how you have that programmed, it will remain connected to source one. So before you even can start the generator, your energy storage system will come online first, providing power. If for whatever reason that outage would last longer than 3 to 4 hours, whatever the energy rating that energy storage system is rated for, then the ATS will truly detect the utility outage, right? The energy storage system is hit a low battery alarm, and then the ATS will transfer over to the generator. Just to give you some ideas, there's different ways to configure these. If you have a design in particular where you want to go battery first scenarios, there's different ways we can approach it. But these are some of the common architectures that we're familiar with and can support you on these designs. So we'll highlight the middle one there, battery versus generator. Here, this is for a K through 12 facility where they had an automatic interconnection switch there. You can see off of the main switchboard, the first breaker there to the left is connected to a transfer switch, which is connected to their own essential loads. We call these essential loads because, again, we don't want to specifically reference them as emergency loads. They could be legally required loads. We really just recommend the consultant or client to define what those loads are. The non-essential loads are the loads on the main switchboard that don't require emergency power. They can remain dark in the event of the outage. And if you go there to the far right, you see the microgrid interconnection device. And upstream of this microgrid interconnection device, you see this switchboard. We can call it a critical switchboard, where you have your energy storage system, your solar system, and essential loads connected. And this is the ideal configuration for a microgrid interconnection device, because here, those essential loads are already separated in that critical switchboard upstream the microgrid interconnection device. So the event of an outage, you're not providing power. The energy storage system is not providing power to those non-essential loads in your main switchboard. It's only providing power to those essential loads in that critical switchboard. So we'll go through this animation, and you can see how each of the ATSs operate, how these inverter systems come online and shut down. When there's an utility outage, your entire system will go dark here. Everything that was once green is now black. That signal, and these inverters inherently, once they experience a utility outage, they're great interactive devices, so they're dependent on an anchor resource, the utility. So when they experience an outage, those inverters shut down, and they will remain shut down until they get some type of signal from a microgrid controller, i.e. a microgrid interconnection device or a more advanced microgrid controller to signal that we're safely disconnected from the grid. Now here, because the ATS is already separate, has its providing power to its own respective loads, and the microgrid interconnection device providing power to its own respective loads, they both operate independently here. So SourcePack will detect through the controller that there's been a utility outage. It will open the electrically operated breaker. At the same time, the controller will signal to the inverter system of the battery energy storage system or energy management system supervising the entire microgrid that we're safely disconnected from the grid. At the same time, the generator will signal, the ATS will signal the generator to come online. Again, the generator takes about 4 to 6 seconds to come online. The energy storage system with the inverters will come online almost instantaneously. That energy storage system comes online, where it's now providing power to those essential loads in your facility. Again, we've isolated those in that critical panel board, as well as the solar system. So if you're looking to use your solar system in parallel with the battery, perhaps you can downsize the energy storage system in parallel with the solar to add additional capacity. Different ways to design your system here. And in this design, the client want to use both battery energy storage and solar for emergency power. While remaining disconnected from the grid, the ATS transfers from utility to generator, providing power to its own essential loads. Now, when utility is restored, the ATS will detect that utility is available. When utility is restored, both ATS and microgrid interconnection device have a 60-minute, retransfer delay. So you can program that device, before we transfer back to the utility source, allow up to 60 minutes. That can be programmable as well. It can be 1 minute, 2 minutes, 5 minutes, depending on how utility responds. You can program that. So as utility is restored, SourcePack will signal to the energy storage system after a time delay, go change state from grid forming to grid tied. And SourcePack is constantly monitoring the inverter-based power at the bottom of that breaker. And once it detects that the inverter-based power hits at 50% the nominal rating, it will close that breaker. And then once again, your energy storage system will come online, operating in a grid interactive mode. At the same time, the transfer switch will detect utilities been restored. Depending on how you have that transfer switch configured, it could be an open or closed transition, hot to hot. It will transition back to utility. The microgrid interconnection device here operates in an open transition. So from the moment that we lose power, there will be a momentary outage where we disconnect and have the energy storage system come online. And then vice versa, when utility is restored, it would operate in an open transition. Now, once that microgrid interconnection device closes, the energy storage system should come online again in a grid interactive mode. As you can see there, that critical panel board, the solar system, and the energy storage system are now operating in the grid interactive or grid connected mode again. And now your system is in normal operation. So this is one design on how generator and battery operate together. The solar system here, solar is very dependent on an anchor resource, and it relies on a consistent either a generator source, a utility, or a battery to provide us steady voltage and frequency to parallel operate in grid interactive mode. So solar by itself cannot provide emergency power for most commercial applications. It's using an energy storage system or some type of generator system that provides that emergency power for your facility. And then of course you have the option to parallel solar, parallel generator with that. There's different ways we can configure this. This is more of a simple microgrid system to enable resiliency. And what's unique about this design is it keeps the equipment standardized. So this is still a traditional main switchboard. the microgrid interconnection device comes with the controller. It signals your microgrid system to come online in island mode, really keeps everything standardized. And again, this was a K through 12 application. So, bid spec jobs, we want to keep the pricing competitive and, keep it really standardized. So we're really not providing an over premium, over specified product for the application. So product specs, this is a NEMA 3R device. So it can be installed outdoors, line of sight of the energy storage system. It's available in 4 SKUs. We have this available in 480 and 208 volts, 600 and 800 amps, and has a withstand closing rating of 100 kA. This can be wall mounted. This could be placed indoors next to the main switchboard. Wherever you have space in your facility is relatively small. And those are the dimensions there. I think we're looking at about 36 inches in width, about 50 inches in height, and about 16 inches in depth. So relatively small product. But again, it's there to provide grid isolation, ideally for those lighter commercial industrial facilities where they want to add an energy storage system and use it for resiliency as well. And this is the energy management system. So Schneider uses an energy management system or a software backbone called EcoStruxure. And how this operates is, these at the very bottom, we have these connected products. The connected products could be something like SourcePack. It could be a transfer switch. It could be an energy storage system where we communicate information in real time to those products on how to operate in the event of an outage. There's an edge controller. So an edge controller is on site. As I mentioned, SourcePack has a very basic microgrid controller. So it does a lot of this operation of the microgrid, i.e. opening the electrically operated breaker to allow the microgrid to enter an island mode. But most microgrid systems require this edge controller on site to open and close breakers and instruct the microgrid how to operate in the event of a utility outage. And then you have the supervisory microgrid software platform, which is a cloud or analytics service that basically monitors the entire microgrid, your PV production. It takes advantage of time of use rates, monitors utility rates to optimize, when to produce, consume energy, or store energy. It really is the intelligence behind your microgrid system, right? And most energy management systems will offer this type of service, but this really offers the next level, you could say, analytics to make sure that your microgrid is making money for you. And additionally, for specifically those grid connected services where your utility is present. And this is the block diagram that we like to show. It's like a reference architecture. So if you're considering designing with an energy storage system, this would be the ideal scenario where you have your main switchboard. Downstream of your main switchboard, you'll have this SourcePack or microgrid interconnection device. And then you'll have this combiner panel or critical panel board where you have your essential loads already connected. This keeps, again, the equipment standardized. So a basic main switchboard, it could be 2,000, 3,000 amps, depending on the kW rating of your energy storage system. You're sizing that correctly to your panel board. So again, you're sizing it correctly to what that full load amp output of the energy storage system can produce and attaching your essential loads there. So when you experience an outage, you're safely disconnecting from the utility, the primary service, enabling that microgrid or that energy storage system for emergency power. And you still require, if you want to take advantage of the grid connected services, you still require some type of energy management or cloud service. And again, that could be provided through Schneider or someone else, but you will also need that supervisory network to oversee your entire microgrid system. And that mainly entails, again, taking advantage of time of use rates, peak shaving, self-consumption. If it's a sunny day and you're producing a lot of PV, have the availability to curtail PV production. That all comes through that supervisory energy management platform, which can be provided by Schneider or, again, a third party. And this is the all-in-one energy storage system. So most energy storage systems, as I mentioned, come within a SKU of like 100 kW to 1 megawatt. Those are the most common ones. Now, Schneider offers ones that go up to 60. Those are a hybrid, which combine your battery and PV energy sources into one bidirectional inverter. And we offer that up to 90 kW. Then we jump up to a 250 kW energy storage system up to 500 kW. We have the capabilities apparently, at least 4 of these, to get you 2 megawatts. But to give you a size of these energy storage systems, the small is a 7-foot container for us. And that's, an industrial container that's designed to be installed outdoors. And then the next size up is the 250 kW, which is a 20-foot container. Depending on where this energy storage system will be located, AHJs have different requirements on clearances. So we definitely recommend you get in contact with the local jurisdiction to understand the installation requirements. But these are all in one. They come with the inverters, the batteries, the battery management system, the output transformer. They're specifically all in one. They're UL listed for 9540, which is the UL certification for energy storage systems, battery energy storage systems. And then also comes with the UL 9540A, the lithium ion thermal runaway listing as well. So in the event of a thermal runaway, that's compartmentalized and kept within each section respectively. But this is another product that we offer as well. A lot of information can be given here, cut sheets. So if you guys are interested, just please let us know. Happy to assist the audience here. And these are our resources. So if you want to get more information on SourcePack, how it, kind of highlight what we talked about earlier, how is it different, what's the value proposition, we highly recommend clicking on our brochure. We have a data sheet there where we have our latest SKUs on what products are available. It gives you overlook of the SourcePack product. We also have our wiring and outline drawings. So if you want to learn more about the communication signal of that relay and how it interfaces with the inverter-based resource, you can find it there. Most of our successes have been with controllers that can accept Modbus. So if the controller can program a C-form contactor relay, convert those signals into Modbus and accept it in the controller, our system is compatible with that controller. So that's really the compatibility piece. And most manufacturers that we work with have been willing to accept our C-form contact and convert that into the Modbus mapping point in their controller so they can communicate with SourcePack. When we detect a utility outage, it receives our signal and then it instructs the inverters to operate on the next steps. And then we have a couple white papers, a case study that's coming out for one of the single line diagrams that I've talked about earlier, as well as the installation manual here. So if you go through our SourcePack controller, it goes through entire sequence of operation. So very useful if you're looking to commission or test the system, right? A microgrid system, an energy storage system for backup power. It's a good almost checklist there you can kind of reference to go step by step to make sure that you're following the sequence and making sure your energy storage system is operating correctly for that emergency or resilient scenario. And that's our QR code here. So if you have more information, feel free to scan that. Again, all those documents I referenced in the prior slide will be available here. And I think we wrap things up. So I'll leave it open for Q&A. Victor, I hope you've been answering the Q&A chat, but yeah, we'll keep it open right now.
There have been a couple that come in, but I'm going to welcome anyone else now that we've kind of concluded the official content to drop in additional questions. I answered a few. Some I waited till now to answer, so let me go through a few of these. Role the SourcePack play in ensuring the resilience and reliability of a BESS within an evolving energy landscape, especially with regard to grid stability and demand response. So SourcePack is really providing you the ability to function grid tie when you want to and function as a off-grid system when you want to. So although some other master microgrid controls might be required above it, it would be working with SourcePack that when you want to be grid connected and pulling power from utility as well as from your DERs, it will be closed, allowing you to pull in parallel from both those sets of sources, and your master microgrid controller would be kind of managing how much from each side. However, when you want to go islanded mode, that would come down to the external microgrid controller that's kind of doing the more high-level control of the entire system rather than just providing the isolation function, which is what SourcePack does. And SourcePack could be the device that would open to give you the ability to run in a almost like a peak shaving mode or a demand response type application if you needed to. So I think that was addressing one of the questions. What section of the NEC covers the system? I think that question actually came in right before Benny covered it. But as Benny went through the presentation, I think we had some code excerpts there from various articles within the 700 family. So 700, 701, 702, 705, 708, talking about the fact that battery systems are now allowable sources for backup power applications, even legally required in Article 700 applications, as well as the requirements for a interconnect device, and specifically a listed interconnect device to provide the isolation and the paralleling connection to the utility when you're operating and everything's okay and you want to be grid tied, or when power goes out and you want to open up and be isolated so that you can power your critical loads on that branch. So I think Benny covered that, and when the presentation goes out, you'll see all those excerpts that were referenced by Benny in the presentation.
Yeah, correct. And that's 700.12 in the National Electric Code. So yeah, once you download the copy of the presentation, you can reference that. And then if you have more information, you feel free to look at the NEC code, but it's 712 where we reference that.
So then there were a couple questions around how can this be used with generators as part of the microgrid, right? Benny, towards the end of the presentation, did cover some architectures with generators as a battery first application, or as a battery plus generator for different branches in the system. If you want to run in generators or parallel, there's an added layer of controls that's required. It's really difficult to answer that question on a webcast like this right now because there are so many different sequences that could be desired from that. These two, I would really invite, I'm sure Benny from the sales point of view can maybe get in touch with you guys or somebody from our team, or you guys can reach out to us and talk through the specific application and the sequence that you desire, right? Because just knowing that there's generators on the system, there's still so many questions on, do you want to prioritize battery before generator? Is it about base loading? What exactly is the desire there? So we'd have to go through those questions to really answer that. So yes, there are ways to play with generators. In some cases, it's easier than others, depending on those sequences, but it's all going to come down to the specifics of those sequences.
Yeah, and then specifically what kind of would highlight the products is the kW size of those energy assets, DERs, right? What size is the generator, what size is the PV system, and then what kind of loads they're supporting. And then from there, we can offer some recommendations, but there are ways to configure it. We just ask that maybe you just email us or we look at the chat and then reach out to you guys to kind of walk through some different scenarios, because each one will be different in its own way.
And the last question is around disposal of hazardous waste from batteries. And I don't think either of us can comment on that. So we've been talking more here about the distribution side than the battery energy system itself. The battery energy system providers, be it Schneider Battery System or others, they would have their own processes and recommendations on how to handle batteries at end of life and things like that. I do know Schneider, one of our sustainability targets is to have very clear end of life procedures for all our products on how they can be disposed of safely and sustainably for at the end of their operational life cycles. So I'm sure that our battery energy storage system team has that kind of direction. But today, Benny and I are more on the distribution and power management side than experts on the battery system specifically itself and the batteries. So we can definitely help connect you with those right people on the Schneider side, or reach out to whichever battery system you're looking at, and I'm sure they can provide guidance on how to handle those procedures at the end of its life and those potentially harmful substances. And I think that kind of, I think I just saw one more pop in right now. Is there a different NEC article for life safety in healthcare facilities? So healthcare actually gets a little bit interesting when it comes to the National Electric Code and NFPA overall. So there are requirements within the National Electric Code, NEC 70, NFPA 70 around healthcare, all within, again, for the life safety loads and backup power, all within the 700 family of aspect and articles. But there's also additional requirements within NFPA 99. I always mix up 99. Yeah, 99 is healthcare. NFPA 99, which is specific for healthcare facilities, it does have its own set of additional requirements on top of that. So you got to look at NFPA 99 as well to coordinate any questions for healthcare and consider requirements from both NFPA 99 and, assuming you're talking about backup power, Article 700 of the NEC NFPA 70. So look at both of those. Again, I've been involved with NFPA for several years now, and I do know there's been a slow push towards trying to centralize all the healthcare requirements into NFPA 99 so that you don't have to look at both, but that's still an ongoing process. So for now, you kind of do have to look at both NFPA 99 and an FPA 70 to make sure you're fully covered there. Last call for questions, but if not, I can turn it over to the host, to our host, and close this out for today.
Great. Thank you so much, Victor and Benny, for all that great information, very detailed. Yeah, just a reminder that if you'd like a copy of today's presentation slides, they can be found in the related content module on the left side of your screen. And to receive your CEU certificate, you can submit for credit and download a certificate by clicking on View Certificate in the Earn Certificate module. Lots of certificates in there. And so today's webcast is also being archived and recorded. So if you want to review and watch this, it will be posted on facilitiesnet.com/webcast. And that takes about 24 hours, but in about a day, that will be posted and live there. And that is all I have to close things out. But before I do, I guess just want to say, or ask Benny or Victor if you have any final thoughts for our audience before we officially close things out.
I did see one last question come in about NFPA and if there's going to be a booth. I believe ASCO will be part of the larger Schneider booth. And just earlier today, I was asked if I should attend. So either myself, Benny, or one of our colleagues, somebody will be attending for it. So if anybody's interested in asking questions, there will be somebody there who can answer questions to answer that piece. But other than that, no, thank you for having us. It was great to be able to educate the market. One of the things I think is the microgrid and energy landscape market, unlike the generator ATS market, is still very new and evolving and is not as standardized as ATS is. You go to anyone and you tell them I want a generator, everyone knows how to slap in an ATS, how to slap in a generator and make it happen. Maybe I'm generalizing, but they get the high level concepts. The new energy landscape and DERs is something that the entire industry is kind of figuring out as we go, from a codes, standards, products, applications point of view, and being able to help educate and kind of try to drive some of that standardization is great, and it helps us all work better together. So feel free to reach out if you guys have any questions, and we're happy to help.
Yeah, Victor summarized it pretty well. We're here as a source, here code education. A lot of this is new technology, and really trying to assess the fundamentals, understand the load facility, those use cases that we talked about earlier, and then from there really driving design and the spec requirements needed for your facility. So happy to get in touch with anyone after this. Hopefully we can share the contact list and then we'll go from there. But thank you again for setting this up.
Perfect. Yeah, thank you guys so much for all the great information today. We really appreciate it. And with that, we will end today's event.